All right, so this is the second example for the first derivative test. Originally I had made a mistake in this problem, so I'm going to redo this so that you can see the correct version of the problem. So our goal in this problem is to find all local extrema as well as increasing and decreasing intervals. So we're going to apply the first derivative test to find the local extrema. In order to do that, we're going to need to find the first derivative. So the first derivative here, let's make that a little bit smaller. The first derivative, using the chain rule, is 2/3 x squared minus 4. Using the power rule, that'll be to the negative 1/3 power, and then multiplied by the derivative of the inside, which is 2x. So if we simplify that and move the negative powers to the denominator, I have 2 times 2x, which makes 4x in the numerator. In the denominator, I will have 3 times the cube root of x squared minus 4. And in order to find our critical numbers, we're going to set the first derivative equal to 0. We know that we're not allowed to let the denominator equal 0 because division by 0 is undefined, but that's where the derivative is undefined, which gives us two more critical numbers. So if f prime of x, whoops, not f prime of x, I meant x, sorry. So if x is equal to positive or negative 2, the first derivative is undefined, so these are two of our critical numbers, and then we're going to set the numerator equal to 0, because if a fraction value is equal to 0, only the numerator can equal 0, so we get another critical number of 0. So to test this out, we're going to create a number line, and we're going to name it first derivative. So there's my first derivative number line. Make sure that you name that. I'm going to put my critical numbers on here. I have a critical number of 0, a critical number of negative 2, and a critical number of positive 2. I'm going to test a value in each region, and I'm going to substitute those into, this is why we name the number line, into the first derivative. So the first value that I'm going to substitute is a negative 3. So I'm checking out this region right here and substituting a negative 3. Now let's look at the denominator. We're going to square the negative 3, and that's going to make a positive 9. Minus 4 is going to be positive, so the denominator is going to be positive. The numerator, when I substitute a negative 3, 4 times negative 3 is negative 12, so we have a negative divided by a positive, which is negative. Therefore, the original function decreases on that interval. From negative 2 to 0, I'm going to substitute so I'm in this region right here, I'm going to substitute a value of negative 1. When I substitute a value of negative 1 and square it, that'll make positive 1. Minus 4 is negative 3, and the cube root of a negative is a negative. In the numerator, when I substitute 4 and I substitute negative 1, that makes a negative, so a negative divided by a negative is a positive. Therefore, the original function is increasing. On the other side of 0, I'm going to substitute a value of 1. So the numerator will be positive. The denominator will be negative. The original function is decreasing. And finally, in the last region, a number greater than 2, like 3, would give me a positive in the numerator and a positive in the denominator. Therefore, the original function is increasing. Now, from the last video, well, I'll go ahead and write these up. So I would say that f of x, original function, it's always about the original function, is increasing on the interval from negative 2 to 0 and the interval from 2 to infinity, because the first derivative is greater than 0. The original function f of x is decreasing on the intervals from negative infinity to negative 2 and from 0 to 2, because the first derivative is negative or less than 0. All right, for my local extrema, I can see a local minimum here and a local maximum here and a local minimum here. So I have two local minimums. So I would say f has a local, I'll start with the max, max at x equals 0, and here's my y value, is f of 0, or original function, because the first derivative at 0 is 0, and the first derivative, be careful that you name everything correctly, the first derivative changes from, see we're doing the max, positive to negative. All right, and now I'm going to see if I can write up the other one, the other two minimums together. Let's see how well I do. So f of x has local mins, you can say relative instead of local, at x equal to negative 2 and x equal to 2, and are f of negative 2 and f of 2 respectively. What that means is the order the order of the x values match the order of the y values. And now I'm going to state my reasoning why. Because f prime of negative 2 and f prime of 2 are undefined, and the first derivative, f prime of x changes from negative to positive at these values. Okay, so I hope that helps. That's example number 2, so update your notes with that.